Hello everyone. In this tutorial, I'd like to discuss the definition of the line integral, which is the integral of a vector function or a function that gives a line. Many times, in problems involving line integrals, you will not be given a vector function explicitly, so it is important to remember how to reparametrize a function, or more simply put, get a function in terms of a third parameter. For example, the parametric form of a circle is x equals r times cosine of angle and y equals r times sine of angle, where the angle would be the parameter because r is a constant in a circle. We next say that a vector function is smooth if the derivative is continuous and is not equal to 0 at every point, because remember, the derivative gives us the tangent at the particular point we compute the derivative at. This helps us formally define the line integral as the line integral with respect to c, where c is shorthanded for curve, of a vector function f x comma y with respect to change in arc length. We next recall from what we proved in Calculus 2 with parametric equations. The arc length is given by a formula square root change of x over change in parameter squared plus change in y over change in parameter squared with respect to change in parameter. This means we plug in this longhand form of change in arc length, and we next notice that the arc length is nothing more than the magnitude of the derivative. So we substitute this in and get the final answer for the formula to compute a line integral. So if we are told to evaluate the line integral of this function along the line x squared plus y squared equals 16, and the line specifically follows a counterclockwise direction, we would first do the parametric formula for a circle, and see that the formula that gives us the right half of a circle is given by the angle t is in between negative pi half and pi half. We now compute the derivatives of x and y with respect to change in parameter, so we can plug it in to the formula for arc length involving a square root, and we get the arc length is exactly 4 times change in parameter. So now we plug in the limits for the parameter and the integral, as well as what we found for change in arc length, and finally substitute in the parametric formulas for x and y, even though x and y were literally given in the original problem. We now isolate away all the constants from the integral as we would usually do, then compute the integral using u substitution, and we get a final answer of 8,192 over 5 for the value of the line integral. We can discuss piecewise smooth curves next, which are smooth curves that can be broken into sections of smooth curves that are easier to find, similar to how piecewise functions work in terms of normal functions. So this would mean that the line integral of the total piecewise curve is the line integral of all the individual parts added, like so. So if we are asked to find this line integral along this graph, we would first have to get the x and y's in terms of a parameter, and see visually what the limits of the parameters are for each part. We next do the change in x over change in parameter and change in y over change in parameter for the arc length formula, and then compute the integral of this arc length with respect to change in parameter, making sure to also pay attention to the fact that in each part, the x component will have a different parametric formula. It will not be the same, and we are given x in the original problem. So once we compute all of the integrals individually, we simply add them to get the integral asked, and we get a final value of negative 5.732. Now that we've looked at the most simplest type of line integral, we can discuss more sophisticated line integrals next. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.